steps. The first option is shown with steps 1 and 2. I don't believe, no, it doesn't actually show you the second option. Right here, I'm going to highlight this second option here. Because for me anyway, I mean, both processes are perfectly valid and they both work just fine. However, I think you know by now, I prefer the most efficient way of working through a problem that takes the least amount of writing and can get you there a little bit quicker. And so this is the method that I certainly prefer. And I'll show you why once we go through the long version through example 4. So let's just go ahead and get a quick gauge of what this looks like using just regular rational numbers. No expressions or anything, no polynomials, just numbers. So in this particular complex fraction, what is the least common denominator of just the numerator? What would the common denominator be of the numerator up here? 6, yeah. So common denominator is 6, which means the first fraction would be multiplied by 3 over 3, and the second one would be multiplied by 2 over 2. Everybody okay with that? So if we do that, we multiply this one by 3 over 3, so that would be 3 over 6. Let's just go ahead and work through this problem real quick. 3 over 6, and then plus 2 over 6. So that's our numerator. And then on the denominator, what's our common denominator of the denominator? 4, yeah. Thank you. The common denominator of the denominator is 4, which means our first fraction needs to be multiplied by nothing. So that's just 1/4. And then the second one gets multiplied by 2, so minus 2/4. And then you can simplify both of these fractions, which would be 3 plus 2 is 5. So this would be 5/6 numerator over, let's see, 1 minus 2 is -1. So that'd be -1/4 on the denominator. What's that? We don't need a common denominator anymore because we're already done with adding and subtracting. If you're not adding or subtracting and you're multiplying or dividing, you don't need a common denominator. What we're going to do now is we're going to take 5/6 and divide by -1/4, which would be 5/6 times reciprocal 4 over -1. So this is going to be 5/6 times 4 over -1. And then we can just multiply straight across the numerator and denominator and simplify, or we can use our cross canceling before we do the multiplication, which that is my personal preference. So these are each divisible by 2. So the answer is going to be -10/3. So that's the answer to this complex fraction, or simplified version of this complex fraction, -10/3. Now that's the long way. That would be simplifying the numerator and the denominator separately. If we use this second method that I highlighted in blue here, figure out the least common denominator of all the denominators, both on the numerator and the denominator. So least common denominator of the numerator and least common denominator of the denominator. And then multiply every single fraction by that number, not numerator and denominator by that number, just by that number. So for example, I'm just going to write out the problem again. And we're going to have 1/2 plus 1/3 divided by 1/4 minus 1/2. All right. Now, if you were finding a common denominator for all of the denominators, what would it be? 12? Stands to reason. Because we have 3 separate unique factors here. We have 4, 2, and 3. And if you multiply those 3 together, that gives you the least common denominator of all the denominators. So 4 times 2 is, wait, it's not, no, that'd be 24. It is 12. 2 times 3 is 6, 6 times 2 is 12. 4 goes into 12, 2 goes into 12, 2 goes into 12, 3 goes into 12, right? So the least common denominator is the least common multiple of all of those, which is 12. So if we multiply everything by 12, all 4 of these fractions on the numerator and the denominator by 12. Again, this is my preference for actually solving a problem like this, because for myself, I find it to be a lot quicker, especially when we get into working with polynomials and variables. I find it much more efficient, especially once we introduce those. But the nice thing here is that, let's see, 12 divided by 2 is what? 6. That's a whole number. 12 divided by 3 is what? That's a whole number. What's 4 plus 6? Yeah, okay. 4 plus 6 is 10. Good. And then on the denominator, what's 12 divided by 4? 3. What's negative? That's a negative. So 12 divided by 2 is 6. But it's a negative. So this would be 3 minus 6, which is what? Negative 3. One step. As opposed to like 4. So I definitely prefer this. I find it to be a lot more efficient. I find it to be quicker. I find it to be simpler as well, because you don't have to figure out like, okay, what's my denominator here? And then you keep the fraction on the fraction, the other fraction over the fraction, and then you got to do the dividing a fraction by a fraction, which equals multiplying by the reciprocal. There's just a lot more room for things to go wrong when you introduce more steps into a process. Whereas here, it's like a step, which again, both are perfectly fine to use. I much prefer this. So let's have a look at what we get when we see polynomials. So we're going to go with the longer, more complex way first, in my opinion. And then we're going to do the shorter, less complex way, in my opinion, second. So we're going to simplify our complex fraction, which is x over y plus 1 over y over x minus 1 over y. So we're going to determine both of the common denominators for both the numerator and the denominator. So the numerator is written separately here. And if we have a denominator of y here, this denominator here technically would be 1. So you could write 1 over 1. What's the common denominator of this fraction? What is it? 1 what? One y, yeah, or just y, yeah. So common denominator is y of the numerator. Now the denominator is here. The common denominator of the denominator would be what? xy. Yeah, we have two unique factors on our denominators, so that means those both need to be multiplied, which is least common denominator here is xy. So the way this is going to work is the least, and it actually tells us right here, the least common denominator or the least common multiple of the numerator is y. And the least common multiple or least common denominator of the denominator is xy. So what that looks like is if we multiply this fraction here, I'm going to show you the work. This fraction doesn't get multiplied by anything because it already has the common denominator of y. However, this one needs to be multiplied by y over y. And when you do that, the x over y stays the same. 1 times y over y is y over y. So that's where we get that from. Now on the denominator, we have a common denominator of xy for these two denominators. And so in order for this first fraction to have xy on the denominator, we need to multiply by y over y. And for this one to have a denominator of xy, we need to multiply by x over x. Remember, we're multiplying by x over x. We're multiplying by the factor that the denominator doesn't have on that particular fraction, so x over x. All right, when you do that multiplication on the denominator, you get y times y, which is y squared, over y times x, which is xy. On the numerator, or not on the numerator, on the second fraction, 1 times x is x, so minus x, and then x times y is xy. And then we simplify. We can put everything over a common denominator on the numerator. X plus y over y is here. And then on the denominator, we have y squared minus x over xy, the common denominator for that. Are there questions at this point? So we're basically just doing multiple of the same types of problems that we did yesterday. We're looking at the top fraction as its own thing. We're looking at it as its own problem. We're subtracting it using common denominators. We do the same thing with the denominator. Simplify the numerator, simplify the denominator. Once we have that, we are then going to divide the fractions by multiplying by the reciprocal of that second fraction. So x plus y over y divided by y squared minus x over xy is going to be the same thing as x plus y over y times the reciprocal, which is xy over y squared minus x. Then we're going to eliminate common factors. Because we're multiplying, we can do our cross-canceling system here. So this y can cancel with that y. Now, why are we not canceling out any x's or y's across this way? Who can tell me that? Why does that x not cross out or cancel with this one or that one? Because, yeah, it's subtracting. It's not a multiplication. This minus x is not a factor. It's just a minus x. This y is a factor because it's by itself and it's being multiplied. This x and that y are both factors as well because it's x times y. Y squared minus x is a factor. The minus x itself is not a factor. This y squared itself is not a factor. Those two things combined are a factor. X plus y is also a factor, not separate factor. Yes.
If say there were another negative x on the numerator of the other equation, could it be technically a factor?
Only if there's a y squared in front of it. Because what we're looking at here is that. So if there was an x plus y on the denominator, or there's a y squared minus x on the numerator, then yeah, we could cancel one of those out. But factors need to include the same elements. And since, yeah, we'd have to have the same. So good question. All right. Keep going here. Multiply. And this can be your answer if you want to. X times x plus y over y squared minus x. Or you can distribute the x and get that as your answer. Now, that was, let's see. Let's count up the number of steps this took. 1, 2, 3, 4, 5, 6, 7, 8 steps. We can do this in 1 step instead of 8 by using the other method. So let's write this off to the side. So the same problem using this highlighted blue method here. It's just, I don't know. I want to say it's objectively so much better, but I can't really say that, but it pretty much is. All right. So the problem we're looking at is black for this, x over y plus 1 over y over x minus 1 over y. Okay. So, and if you want to turn the 1 into a fraction, just have everything as a fraction, just put a 1 over 1. That's totally fine. Sometimes it makes it easier just from a visual perspective to write everything as a fraction. So if you look at all 4 denominators, what would the common denominator of all 4 denominators be? How many unique values are there on the denominators? We got a y here, 1 here, an x here, and a y. How many different unique factors are there? Only 2, right? What are they? X and y. So what's the common denominator of all the denominators? Out of all 4 of these denominators, there's only 2 unique factors, x and y. What's that? X, y, yeah. The common denominator, so let's just write this. LCD of all denominators is x, y. So we can multiply all 4 of these fractions, both on the numerator, both on the denominator, by the LCD of all the denominators, which is x, y, which will allow us to do this problem in a single step instead of 8 steps. So here we go. Remember, when we're doing this, we're not multiplying the numerator and denominator by that. We're just multiplying the fraction by that. So xy everything gets multiplied by xy. This is where this process becomes kind of awesome, and especially in my opinion, compared with the other process. So take a look here, xy times x over y. Is there a common factor that we can eliminate from the numerator to the denominator here on this first fraction? Anything we can cancel? X times x, that'll multiply to x squared. But we have a y on the numerator and denominator, so the y should cancel. So that y cancels with that y, which leaves us over here with x times x, which is x squared. And there is no denominator here. It's just x squared. What is 1 times xy? xy, so plus xy. All right, on the denominator, anything we can cancel here on this first fraction of the denominator? X, yeah, the x's eliminate, which gives us y times y, which is y squared. And then does anything eliminate here on the last fraction? The y's eliminate. And then we get negative 1 times x, which will be negative 1x or just minus x. And if you look at the answer down below, that's literally the exact same thing that we just got down here. Let's see, right here. But we did it in 1 step instead of 8 steps. It just seems like a massive savings of time to me. So I don't know. If you prefer the other method, that's fine. I'll think you're weird, but it's fine. That's all right though. Weird as hell. I'm weird. So, questions about that? Cool. Let's try some ones on the last page of our notes. We're just about done with this. So, scoot on over. All right. So let's simplify this guy right here. Now this is multiple choice. And you can use whichever method you prefer. And I'm going to give you, let's say 3 minutes to work on this one. I'll give you 3 minutes to try to work this one out. Whichever method you resonate more with, try it out. Multiple choice, so you got a little bit of a way to figure out what's going on. So. So I'm going to use the least common denominator of all the denominators method here. So what's the least common denominator of all the denominators? How many different unique factors on the denominators are there? Anybody? What's that? Okay, there's a y, and then so there's a y here. That's a one, that doesn't really count. That's a one, that doesn't really count. But then this one has an x, y. So this one has an x and a y, whereas that one just has y. So what is our least common denominator of all the denominators? X, y. Yeah, so there's two denominator factors throughout all four fractions, and the two factors are x and y. So we've got a least common denominator of all the denominators of x, y. So everything gets multiplied by x, y. Now in this first fraction, xy cancels with xy, which leaves us with just x. So that equals x. 2 times xy, that'll be a minus 2xy over. Xy doesn't cancel out with anything because that was a 1 down there. So it's going to be 2x squared y squared because the x multiplies with the x to be x squared. The y multiplies with the y to be y squared. So that's going to be 2x squared y squared. And then let's see, the y will cancel with the y here. So then this will be minus 3x. Now I don't see this answer down here, which tells me that there's still a little bit that we can do. So if you look at the numerator real quick, is there a common factor in the numerator? Does this numerator have a common factor between those two terms? What is our common factor between these two terms on the numerator? X, yeah. So factor out an x. If you factor out an x from x, you got a placeholder of 1. Factor out an x from the minus 2xy, you've got minus 2y. On the denominator. Hudson, have a look at the denominator for me real quick. Is there a common factor down here? What is it? What's that? Of those two terms on the denominator? What's our common factor? What's that? It is x, yeah. Because this has an x squared, that has an x. The 2 and the 3 don't, obviously, they're not common factors. This one doesn't have a y, but this has an x, that has an x squared. So they both can be divided by x. So let's see, that'll be x, and then parentheses, 2xy squared minus 3. And then we have a common factor of x on the numerator and the denominator, leaving us with 1 minus 2y over 2xy squared minus 3. What's the answer? B, yeah. There we go. Now we could have used the common denominator method for the numerator and the denominator and then done the subtraction and then multiplied by the reciprocal and all that business, but it just seems unnecessary knowing that we have this method. And that's actually what it's talking about with example 5. So I want you to work through example 5 on your own because it's basically doing exactly what we just did. I kind of am ignoring that first method just because it's so clunky. So let's just talk about this one real quick, and then I'll have you do the check step at the bottom on your own. So here is our original fraction. X over y plus 2 over x over 2 minus y over x. So out of those four denominators, how many unique factors are there? And what are those unique factors? X2 and Y, yeah. X shows up twice, but it's only one unique factor. So X, the 2, and the Y. So there's 3 unique factors, and it says right here, 2, X, and Y. Therefore, the least common multiple of all the denominators is 2xy. Just multiply those unique factors together. So everything gets multiplied by 2xy on the numerator and the denominator. And we usually start by writing it like this. We don't necessarily write it like this and then show the distributive property. We just multiply everything. So it ends up reducing right here. Now, the numerator actually has a common factor of 2. You could divide out a 2 from the numerator. And on the denominator, you could divide out a y from the denominator, but there are no common factors between the numerator and the denominator, so it's not necessary to factor those out. If you wanted to, you certainly could, just to double check. And you could say, or 2 parentheses x squared plus 2y over, let's see, we can factor out a y here, so that would be y times x squared minus 2y. So you could write it like that. Nothing to actually reduce after that. So there's no real need to factor those out, even though you could. All right. Do this last check step on your own, and then after that, you'll have the remainder of class to be working on the assignment. So take a couple minutes on this one. Check back in at like 8:33, 8:34, right around there. Yeah. What's our least common multiple of all the denominators? 2ab, good. So all 4 terms get multiplied by 2ab. All right. Does anything cancel out when you multiply by 1? Nah. So that's just 2ab. All right. Does anything cancel out with the b squared over a times 2ab? Yeah, what cancels out? The a's, yeah. A on the numerator, a on the denominator. Those are factors, they cancel out. What is b squared times 2b? two B cubed. B times B squared is B cubed. All right. At this point, I think we know what the answer is. Thank you. Cool. So we got two AB plus two B cubed on the numerator, and then on the denominator, anything cancel out down here on the first fraction? With the two, yeah. No, we'd be competing with a leaf blower this morning. All right. What is AB times A? A squared B. All right. Does anything cancel out over here? B. You got a B on the numerator and denominator. They're both factors, therefore they can be eliminated. What is A times 2A? 2A squared with a minus, so minus 2A squared. So what's the answer? A. And once again, we're able to do this in one step instead of 8. So that's it. Cool. That's all I got for you for 9-2. Your assignment, which I showed you yesterday, but just in case you didn't get it written down, is right here. It's a decent amount of problems to work through. I understand that, but we've got over 40 minutes in class still, so be working on that, and then I will collect this on Monday. If you have 9-1 finished and you didn't the other day, go ahead and get that turned in as well.